Hi, in this demo we're going to look at the various parts or classes of a very simple iPhone app in terms of model view controller. So the first thing I want to do is show you how to set up in Xcode an iPhone application. So we'll go File, New, Project, and then we will use, for the time being, under iOS, under Application, the Single View Application template. And we click Next, and we're able to insert the product name and other information here. Make sure your device is set for iPhone. It has iPad, iPhone, and Universal, in other words, for iPhone and iPad. So we've set that to iPhone, and then we click, once we have Next, we're given the opportunity to save our application in a location, and we go from there. So we'll just cancel this for right now because I've already got this set up. Now, the first thing you'll notice is we have this class here called Delegate, and we're not going to talk about that in detail today, but the Delegate is the class that functions as the delegate for the application as a whole. So when the application starts, when it's about to enter the background, when it's about to come forward from background execution, the Delegate has delegate methods that we can respond to those types of events. We're going to start here with the main storyboard. Main.storyboard, or any storyboard, represents the view of our app. So the storyboard will contain all the views of your application. And this storyboard file will be compiled into an actual view class or a series of view classes depending on how many views that you have in your storyboard. And we can add different views. We can add things called view controllers into our storyboard, and each one in the storyboard will be represented by a separate view. Next, we have this class called view controller. This is the controller of our application. View controller, it sets up, it gives you, the template gives you one master view controller. If we need other view controllers, we can certainly set them up. And then we have added a class here called model. What we're doing in this demonstration is just emulating something called the Magic 8 Ball. A Magic 8 Ball was a toy that you concentrated on a question, and then you shook it up, and then it had a little round window with inside a liquid and then an icosahedral shape with triangular faces, and it would have fortunes on it. So what do we need our model to do is the first question. In other words, what is the data that this application is going to be working with? Well, the data the application actually needs is a fortune. Because that die inside the Magic 8 Ball had 20 faces, we need 20 possible fortunes. But we only need to look at one at a time. So the job of our model is to get a random fortune from a pool of 20 fortunes. So let's see how we set up that model. We've got a very simple interface. We have a property that's an NS array, and I've called that fortunes. And then I have a method, a single method. This is an instance method, remember the dash, and this is just called predict. So predict is going to return one of 20 fortunes. Then in my implementation, I have overridden the init method, and I've just called through to supers init here. And then if I get back self and it's not nil, I call setup fortunes. And then finally I return self. Setup fortunes simply looks at the self.fortunes array and sets up the list of possible fortunes as NS strings. So this notation says, give me an array of NS strings and then finally terminate the array. These are the original strings or the original fortunes that were in the original Magic 8 Ball toy. Finally, predict gets an index using arc4random. Arc4random returns a random integer in the range of 0 through long max, or int max. So I have modded that by 20 because this is at index 0 and this is at index 19. So when I mod it by 20, I will get a range integer between 0 and 19 inclusive. And then I return self.fortunes, this is the array, indexed by that index. So the object at the index. And of course it's being returned as an NS string. So this is our model. Our controller imports the model, and now the controller has access to the model and can tell it what to do. Now, notice that I have this property. First of all, I have a property for the model. I should mention that first. Secondly, I have a property, and it has this IB outlet descriptor. IB outlet is for passive outlets on our view. We need to tell it that this is going to be an outlet on our view. And outlets are typically passive controls. It is a UI label. And we'll talk more about what these control classes are. But UI label is just a passive label control. And then I've called it LB Fortune. It's a label, LB, for fortune. Now, we don't have to use this kind of syntax. This is just kind of my habit. I like to precede my labels with LB and my buttons with BTN and so forth, so I know what those properties refer to. I have a method, button pressed, and this is a method that returns void, but I'm taking in something called sender here. Sender is the actual control that is pressed, so we can get to the sender's properties by using sender. However, it returns type IB action. Well, IB action is a flag to the system, to Xcode, to say that we have defined it in Interface Builder, IB, just as IB outlet is a flag to Xcode to say that we had defined an outlet in Interface Builder. IB action is a type def to void. So this actually returns nothing. IB outlet is a define to nothing. So don't worry about what these actually are. Just know that if we want an outlet to our view from our view controller, we need to use this keyword IB outlet. And if we want an action method, we need to use this keyword IB action. Now, we see these little circles here, and they are not filled. This means that we have not wired the property and the action method up in our storyboard. So let's go ahead and see how that's done. We go back to our main storyboard, and if we look at our view controller, which is represented by this view controller class, if we right click, we'll see this menu pop up. And we see that view controller, and then we have a section for outlets, and here is label fortune, and that is going to map to this label right here. So I'm just clicking and dragging from this little circle here to our label, and this is where our fortune will be displayed. And now it's set up, and when I hover over it, I see that empty label. And then received actions, I have my button pressed action, and now I'm going to do the same thing to my button, and when I release, I get the possible events that can happen on that button. The one that we're looking for a button is touch up inside, meaning that the finger left the screen while it was still inside the area of the button. So I'm going to map that. And I see that button pressed is now mapped or wired to my button, then press here, and the event is touch up inside. So now I'm pretty much ready to go. The only thing left is to define what happens in our view controller. First of all, the model needs to be instantiated. The simplest way to do this is to override model's getter to return an instantiated model if it doesn't exist. Remember that I can get directly to the ivar. I don't want to say self.model inside the getter because self.model will call the getter. If I say if not self.model, this will call the getter. That would be bad. That would be recursion, and it would be unintentional. So what we say is if not underscore model, in other words, directly the ivar. So if model is not equal to nil, then underscore model is equal to model alloc init. And then that will set up my fortunes array, as we already saw, within the model. So the model is ready to go at that point, and then I return underscore model. Button pressed just sets the fortunes, the label fortunes text property to whatever comes back, the NS string that comes back from the predict method in the model. And then these other two methods are not strictly necessary in this code, but these are delegate methods that belong to a controller in iOS. ViewDidLoad will be called when the view loads onto the screen, and didReceiveMemoryWarning will be called when the system is about to kill the app due to a memory constraint. So we're not going to worry about these two just yet, but ViewDidLoad is very important. didReceiveMemoryWarning is also important, but we'll talk about it later. So now when we run our app, remember we've got our model, we've got it hooked to a view controller, and then we've got a view in the storyboard that will be compiled into a view class that is also hooked to the view controller. And now when we run it, everything happens in the controller as we know. And we have target action from our button to our event, to our action method. And we have, well, actually in this one we don't have delegation, but we certainly could from the model to the view controller. But we're keeping it simple in this instance. So let's go ahead and run it, and we see that we have the label. By the way, this is a purely passive label. This is not wired to anything. It's just always going to display, concentrate on your question, then press here. And then we get one of the 20 fortunes every time we press the button. And that's it. Thank you very much.